This example is a little bit different than the previous ones we've worked. We're going to use the normal model to solve this problem, but we're going to use it in a different way. Here's the problem. Suppose that the mathematics SAT scores are normally distributed with a mean of 500 and a standard deviation of 100. And the ACT scores are normally distributed with a mean of 18 and a standard deviation of 6. If a school only accepts students with SAT or ACT math scores in the top 10%, what are the minimum ACT and SAT scores that would be acceptable for that school? Now, let's think about the kind of information we were given here. We were given the traditional mean and standard deviation for the SAT and the ACT. So that's sort of standard. What's different about this problem is that they gave us a percentile. They're interested in the top 10% of scores. And more specifically, they want to know what score on the SAT would separate the top 10% of students from the bottom 90% of students. So this problem's a little different than our last because we're going to need to work this problem backwards. That is, typically when we work our problems with a normal distribution, our output at the very end of the problem is a percentile. And that's what we're usually seeking out. In this problem, our input is the percentile, and the end result is an actual value in our data set, an actual SAT score. So this problem has presented itself completely backwards. So we want to go and we want to take a look at this problem. I'm going to give you a nice image here. This is the bell curve, the normal curve, with a reminder of the mean and standard deviation up top. And visually, this is how I want to divide my curve up. Here is my top 10%, right up here. So if 10% is above, then I said earlier, 90% would be below. So I wrote these guys in as 0.9 and 0.1. So the only thing we're lacking is, right there with a red question mark, what's that score? It's clearly above 500, it's above the average. What score would separate the curve in this way? Now, we need to look something up, a percentile, in the normal tables. The question is, what do we look up? Now, remember, the normal tables, when you use them in our traditional way, we always know that it gives us an answer that's understood to be area to the left. So when we use it backwards, when we give it a percentile, hoping to determine eventually what this SAT score is, we have to give it the percentile to the left. Now it's no problem, 90% coincides with 10%, but in order to get the right answer, we have to give it the one to the left of our vertical bar that's going to split the curve in these two precise pieces. So we're going to look up 0.9000 in the inside of the normal table. Alright, we're going to start on the inside. This is why I gave you the number as 4 digits. We're going to look across here and look for 0.9000. Now it kind of reads like a typewriter. You know, you're going to look left to right and the numbers are going to grow. Oops, the circle already popped up. That's okay. So as we get across here, we're going to notice that we have this number 0.8997 and the next number is 0.9015. Now, that's our threshold of where 0.90 happened, right between 0.8997 and 0.9015. 90% here, 0.9 was achieved there. So it's sort of a toss-up between these two. And I'm going to go with the one on the left because it looks like it's a little closer to 0.9 than the one here on the right. So this is my stand-in for 0.9000. It's the closest I can get. And remember, I'm going to do the opposite of what I'm usually doing. Now I'm going to trace out. So I'm tracing out, just the opposite. Typically in our other problems we traced in. Now we're tracing out to discover the z that would put 0.900 on the left and 0.10 on the right. So if we look, we're in row 1.2 and column 0.08. So if we blend those together for a z-score, we'll find that the z-score is 1.28. Now keep in mind, this is just a standard score. It's unitless, has nothing to do yet with the SAT. But it is the standard score that would separate the curve lower 90% from the upper 10%. Now, we're going to go and now use the z-score. Remember, the z-score is our link between the data values and the standard score. So we're still going to use this link. We know 3 of the 4 pieces here. We know what z is, it's written above. We know what y bar and s are. So we know 3 of the 4 pieces. I'm going to go ahead and fill them in now. So 1.28 equals y minus 500 divided by 100. So this y here is our solution. This is the SAT score that would separate the top 10%. So we have to solve for y. It's going to require a little bit of algebra, basic algebra, to get y alone. The first algebraic step to get y alone is to multiply both sides by 100. Now on the right hand side, the 100s will cancel. On the left hand side, we need to determine what 100 times 1.28 is. 128 equals y minus 500. So 128 is 100 times 1.28. And of course, with the hundreds canceling on the right, we're left with y minus 500. What's our last step in order to isolate our y and solve for it? Add 500 to both sides, and we see that our y is equal to 628. Now this is our SAT score. Back to the curve. Here we are, the same diagram we had earlier, except that no longer is the location of this vertical bar a mystery. It happens at 628. You can see that's nicely well above the mean, so the number here makes sense. If this was 300, it wouldn't make sense to be to the right. So we feel like we did the work correct. It's a number greater than our average score of 500. And we can tell that the minimum SAT score that would separate the top 10% of students is 628 on the mathematics section of the SAT. Now I want you to do the same process for the other test, that is the SAT. You find the SAT score that would separate those top 10% of students. Pause this video, do the work, start it back up, and you'll discover the answer. The minimum ACT score that would separate the top 10% is a score of 25.68. I hope you got it correct. If not, go back, check your work. Maybe there was a silly mistake, or we can discuss it in class later if you're having trouble solving this.